everyone. In the first part of my lecture, there was a discussion on the theoretical concepts of relational algebra and relational calculus. And I told you that relational algebra is a procedural language while relational calculus is a non-procedural database query language. And I also told you that how the relational algebra is a procedural language. For that, I described the table employee. There were various attributes: for first name of employee, middle initial of the employee, last name of the employee, department number, commission, joining date, salary. These were the various attributes. And suppose I have to write a query, for example, retrieve the details of first name, last name and salary of employee where department number is equal to 5. So one way I can write in a straight way this query as pi f name comma l name salary. This is the project operator, which is equivalent to select operator in SQL. Then we are applying a sigma operator where department number is equal to 5, and I also told you that in SQL sigma is same as where clause. And first of all, the inner query will be executed. First of all, on employee relation you are applying sigma operator. This will retrieve the all the details of employees of department number 5. After that you are applying the project operator, which will give the first name, last name and salary of the employee. Why this is procedural? If you break this particular query into two parts, so here you can see, first of all we are applying the sigma operator on employee relation by giving the predicate department number is equal to 5. Then it will give a relation which will have the details of all the employee, having the attributes employee number, first name, employee name, first name, last name, middle initial, salary, joining date, etc. Then this is another relation D1, and again on this D1 we are going to apply the project operator. What is the through project operator? We are retrieving the first name of the employee, last name of the employee and salary. Again this will give the return another relation which will be stored into R1. So in this way every inner query is returning a relation and we are applying operator on that relation. Then in terms we are getting another relation. That's why we are saying that relational algebra is a procedural database query language, while rational calculus is a non-procedural database query language, because we only see there how to retrieve, what to retrieve, not how to retrieve. There is no concern that how the query is returning the records, returning the tuples from a relation, only what information we want and we get through the relational calculus. And I told you that relational calculus is categorized into two categories: tuple calculus and domain relation calculus. There are various relational algebra operators were explained: select operator, project operator, then union operator, intersection operator, minus operator, Cartesian product, join operator, rename operator. All these operators were discussed. So today we are going to discuss more examples on relational algebra and relational calculus. So to understand in much deeper way, first of all we will take three relations. One is student, another one is course and registration. The description of this relation is that students are registering themselves in some courses. Then we have taken three entity types: student, course and registration. The attributes of the student is social security number of the student, name of the student, address of the student and what major subject he is choosing. These are the various attributes where social security number is a key attribute. Then another relation is course. The student age has taken the course which code is given and the title of the course is given. For example, BSc Honors Computer Science, BSc Program Computer Science, so that is the title. Here code is again a key attribute. Then registration relation is there where two attributes are there. One is SSN, social security number, and code. Both are the key attribute here. From the above given semantics, it is clear that the students are registering themselves in some courses. Now, we will solve different problems one by one. The first question is, write a query in relational algebra to list the codes of courses in which students is registered. List the codes of courses in which student is registered. So here only one table will work out here, that is the registration. This is the relation is given, registration, and you will apply this project operator and with the subscript code registration. This will give the list of codes of students in which the student is registered. It will give the list of codes of the courses in which the student is registered. Now see the second example. List the titles of registered courses. So to solve this, here two things are there, registered and courses. So now we will take the join. Now we will take the join of course and registration relation. Both the relations will be joined, and you are seeing that this is the inner join. Why inner join? Because inner join is being applied on the same attribute. That's why we are not giving any condition here. This is a inner join. So the course and there will be inner join between the course and registration, and whatever relation it will return, on that we are applying the operator by title. It will list the titles of registered courses. Okay. Now third question is, list the codes of courses for which no student is registered. Now here, for such type of questions, always we use the minus operator, relational algebra operator minus. So you know that there is a course relation and another one is registered relation. The degree of both the relations are same. Here we are applying project code course minus project code registration. So this will return the codes of courses for which no student is registered. Now let's make it some more complicated. The question is, write a query in relational algebra which will list the title of courses for which no student is registered. Right? So title of courses. So here what we will, how we will do it. First of all, we are retrieving those tuples in which we are getting those students who are not registered in a course. So once you will get that relation will be inner joined by course relation, and whatever relation we will get, we will apply the project operator in subscript title and it will give the desired result. Now, next question is name, write a query in relational algebra to retrieve the name of the students and titles of the courses they registered. Here you see name of the students, it means students table will be involved into this, and titles of the courses, it means courses will be involved, they register too. It means registration table will also be involved here. So here all these three tables, student, registration and course, will be inner joined, and on whatever the relation tuple set of tuples we will get in the form of relation, we will apply project operator and this will retrieve the name and title of name of the student and title of the course. Now, next question is write a query in relational algebra to retrieve the social security number of students who are registered for database system or algorithms. So here the title is given database system and algorithm. Here one thing is given or. It means that we will use the set operator union here. One thing is very clear, that union will be used here. So how we have written this query? Pi SSN. So first of all you are seeing that student inner joined registration, then inner join, where we are applying the condition sigma title is equal to database system, okay, and course union, again pi SSN, again the inner joined, the relation student, registration and course will be inner joined with the title with the condition sigma title is equal to algorithm. If we change this question, a little bit, write a query in relational algebra to list the SSNs of students who are registered for both database system and algorithm title. Here, what we will do? Here you are, as it's very clear that student, registration and courses, all three relations are involved. So first of all, we will get inner joined of student, course, registration and course, where we will apply the condition sigma title is equal to database system, and we will use the operator because and is there, so we will use the operator and pi SSN student inner joined registration inner joined courses with the condition sigma title is equal to algorithm. So in this way you can solve such questions. Now another question is which is based on the division operator, and always in the examination such type of query will be asked. So first of all you must know what is the division operator. So for the division operator, one precondition is there. If two relations are there, A and B, so if we write like this, A division B, it means that the attributes of B must be included in the schema for A, and also the results has attributes A minus B. For example, if we are having two relations, A which is having the attributes S number, supplier number and product number, and various tuples are there. For supplier number S1, the product number is P1, S1 product number is P2, for S1 number is P3, like this. Then another relation is there, which is B, in which there is one attribute P number P2. So there are two relations A and B are given, and if we apply division operator here, so you are saying that it will give the attribute A minus B. So A minus B, here supplier number and P number and P number. So what will be there? The attribute in A division B will be S number. And the second thing is there, what is the precondition? The attributes of B must be included in the schema for A. It means that if you see that pair P2 S1 P2 S1, here P2 S3 P2 S4. So what it will give? It will return S1 S2 S3 and S4. So now let's see the questions. Write a query in relational algebra to retrieve the list of courses in which all the students are registered. List the courses in which all the students are registered. How to write the query? First of all, you will registration relation you will apply project operator, and what you will project, select code and social security number divided by pi social security number, and on the relation student. This will give the all the list of courses in which all the students are registered. So on the division, based of division operator, such type of queries can be solved. Then another question is, write a query in relational algebra to list the courses in which all, suppose title is this, FCMPS major, where the major of the student is FCMPS major students are registered. Here, if we have to solve such type of query, what we will do? We will do registration. We will apply on this relation pi, project operator, code and SSN divided by pi SSN, where we will apply the sigma operator, and in this we will write major equal to FC MPS, right? And this particular pi operator will be applied on this relation student with the condition major is equal to FCMPS. So by using the division operator you can write such queries. Today we will study more about on the outer join. In the last class I told you that outer join is used to handle with the null values if null values are there in the relations, and if relations are related with each other, if tables are related with each other, then we will use the outer join. And to show the outer join in relational algebra, we will use the horizontal dumbbell. There are three types of outer join. One is left outer join, and then right outer join and full outer join. So I told you that if your child table is deficient, then in that case always you will apply the left outer join. If master table is deficient, then you will use right outer join. And if both the tables are child table and master table both are deficient, in that case you will apply the full outer join. Now first of all we will have to understand the concept of left outer join, right outer join and full outer join with example. So let's take an example of two relations where I am taking the relation loan in which the attributes are loan number, branch name and amount. The loan numbers are L17, L23, L26. The branch name is Dev Rao Pia and amount is 30,000, 40,000 and 70,000. So one is loan and another one is borrower of loan. Another relation is borrower of, which is having two attribute, customer name and loan number. So where customer name is Jay, Sai, Harry and loan number is L17, L23, L156. And the common attribute here you are saying that loan number, right? So if we write the outer join, so how to write the outer join? I told you that horizontal dumbbell with the on the right side there will be two parallel lines on the edges. This is the right outer join. So if you are going to apply right outer join over here, here must here in this example if you say if we apply join here, so in the join what all the attributes loan number, customer name and amount and branch name will be displayed. So here you see कि for the loan number 17, 23 and 156. So for 156 loan number there is no loan for the borrower Harry having loan number 156. There is no loan, no branch and no amount. So what will happen? L17 no problem, Dev amount 30,000, J. Here L23 Rao 40,000 this. For L156 since there is no loan, so the value of customer name and amount will be null. So despite of being the since for this loan number 156 there is no loan, so if you will apply the normal join then this particular row will not be shown. But here by applying the right outer join the row having the null value will also be displayed using the right outer join. If both sides are deficient, in that case you will use the right outer join and the symbol for the right outer join is like this and with horizontal dumbbell and parallel lines on both the side. It means that both the tables are deficient. How? You are saying that loan number 17, 23 and 26. Loan number 17, 23 and 26. So for loan number 26 there is no borrower. It means this one is deficient. And for borrower loan number 156 there is no loan. So in this case both the tables are deficient. So in that case you can apply the full outer join and after applying the full outer join you are seeing the loan number, branch name, amount and customer name. Here you are seeing that for loan number 156 the value of branch name and amount is null. Despite of being the null value, the value are being shown in the row, and for L26 there is no borrower, so for that the value of customer name is null. So if again this particular row is being displayed, so that's why we use the full outer join. And in the same way, if child table or left table is deficient, in that case we will use the left outer join, and for the left outer join we use the symbol horizontal dumbbell with the two parallel line on the left. And in the same manner as right, in the case of right outer join we have written the query, in the same way we will apply the left outer join and this will be applied on the loan and borrower relations. Here we are applying the full outer join on the loan and borrower relations, and here we are applying the right outer join on the loan and borrower. Here the borrower is deficient. In the case of left outer join, this loan will be deficient, and the full outer join both table will be deficient. And always this outer join is very important in relational algebra or in SQL also, because they handle the null values. One more topic I am going to discuss in relational algebra, that is the aggregate operators. Aggregate operators always apply on more than one row, and aggregate functions takes a collection of values and returns a single value as a result. In aggregate operators are average, minimum, maximum, sum and count. These are the functions: average function, minimum function, maximum function, sum function and count function. Average function always calculate the average of the value. Minimum function always calculate the minimum of the value. Maximum or maximum value. Sum क्या, sum of the values. Count number of values. And this aggregate operator is denoted by scripted f. This will be denoted by scripted f, and the syntax of this is notation in relational algebra. While writing the query, we will write in this way. The syntax is like this: g1, g2 up to gn scripted f, f1 on attribute a1, function f2 on attribute a2, so on, function fn on the attribute an, which will be applied on any relational algebra expression. Now g1, g2, gn is the list of attributes on which it is to be grouped, and this is the optional. Each fi is an aggregate function, and each ai is an attribute name. So now we will see some questions that will be much clearer. Here, write a query in relational algebra to retrieve the total salary of employees. So again, this aggregate operator we are applying on a relation employee, and I told you earlier that employee is having employee number, employee name, salary, commission, hire date, joining date. So return the total salary. It means that whatever is the salary column, you have to calculate the total salary. So it means that you are applying the aggregate operator scripted f on the group of rows, group of tuples. So how will you write? Scripted f, sum, salary, attribute, and that will be applied on relational algebra expression or relation employee. Now another question. Write a query in relational algebra to retrieve the number of employees who are getting salary. Okay, retrieve the number of employees. Now here you have to count the tuples, then only you will be able to calculate the number of employees who are getting salary. Then what you will do on employee relation, you will scripted f, you will use the function group function count, which will be applied on attribute salary, and that will be applied on relation. So it will show you the number of employees who are getting salary. Now another example you can see, write a query in relational algebra to find total salary of employees department wise. If in the employee table department number attribute is also there, but you are getting the sum of the salary. So on the salary attribute, the group function sum is being applied. So this sum function is being applied on more than one rows. Department wise, where department number is a single value, then you will have to group that. So how to write this? scripted f sum salary, and that will be applied on employee, and the attribute on which you have to group, that will be, because this is a single valued, that's why in this way you will write department number. So it means that it will give the total salary of employee department wise. It means that if there are 4 employees department of 10 number, department number 10, if 5 employees of department number 20, so it will give the total salary of department number 10, it will give the total salary of department number 20, of all employees working in the department number 10 and all the employees working in the department number 20. In this way it will show the result. Another type of join is there, and which is known as recursive closure, when one relation is getting applied on the same relation. In that case, recursive join is used, and or self join is used, and such type of relationship is known as recursive closure relationship. So a relation can be joined itself on column that contains the same type of information. A self join joins rows from a table to another or the same rows in that table. So for example, if we want to write a query to list the details of those employees who are having manager. So this is the, you know that every employee cannot be manager, but manager is in itself a employee. So here we are getting the, we are applying the employee with manager. Manager is in itself a employee. It means that employee relation is being applied on itself. So employee join operator, then manager, where we can write the condition manager number equal to EMP number, and it will give the list of all those employees who are manager. So this is the example of recursive closure. In SQL we tell it the self join. In relational algebra also we can say it the self join. So how to implement the self join? So this is the example of self join. Now another operator I discussed about the rename operator. So through the rename operator returns an existing relation under a new name. So the syntax is, what is the expression notation? Row A B. It means that is the relation B with its name changed to A. So the value, this is the existing table, the name of the relation is B, it will be changed to A. So the syntax is row A and B. For example, if you are existing table employee, if you want to change the name of the employee to EMP2, so in this way you will write the row symbol, it means rename operator, that will be applied on the employee relation, and here the change name will be employee2. Now complete set. What is the complete set in relational algebra? So there are some basic set of operators like sigma, project, Cartesian product, union, minus, row. Right? These are total 6 basic operators, and on the basis of this basic operators you can derive more new operators, like the join operator you can derive, like intersection operator you can derive. So you can derive more operators on the basis of these 6 basic operators, and this is known as the complete set of operators. So a set of fundamental operators is known as the complete set, which are sigma, pi, Cartesian product, union, minus, and rename operator. Any operator which can be derived from the complete set will be a derivable operator. So let's understand with the example. For example, join operator, which is not in the complete set, right? But we can derive it where two relations A and B are there, they are getting joined with the condition C. So which implies how it is coming? It is deriving by using the A Cartesian product B on the Cartesian product of two relations. I have applied a condition using the sigma operator. Whatever the relation it will be returned, relation will be returned. I am applying the project operator here pi a1 a2 up to an. So by writing this expression, you can convert it into the join. So this is the derivable operator from the basic sets pi, sigma and Cartesian product. In the same manner, if two relations R1 and R2 is there, and if intersection operator is there, but intersection operator is not there in the basic sets, so how you can derive from the basic sets? So R1 union R2, basic set theory formula, minus R1 minus R2 union R2 minus R1. So by writing this expression, by using the union operator and minus operator, you can get the intersection operator. These two are the derivable operators. So in this way, from the basic set of operators, we can derive any derivable operators from the complete set. The application of relational algebra is for query optimization, and always it uses whenever you submit a query in SQL and SQL query executes in multiple phases. So there is a phase, query optimization phase, where your queries will be broken into the different expressions, relational algebra expressions, and a syntax tree will be built, and on the basis of that your query will be optimized. So one of the application of relational algebra is query optimization. Now we will see some questions on relational calculus. So as I told you that two types of relational calculus is there. One is tuple relational calculus, which is known as TRC, and another one is domain relational calculus. And in tuple relational calculus, I told you that you will use a tuple variable and which will span over all over the row. It means that we will understand this with the example. Again, I am taking the same table, relation employee, in which there are various attributes: employee number, employee name, which consists of employee first name, employee middle initial, employee last name, salary, department number, joining date, commission. All these sort of attributes are there. So now we will write a query into tuple relational calculus. So write a query in tuple relational calculus to select the employees whose salary is greater than 1000. So how to write the query? Very simple. We will take a tuple variable x, and this x will span to ranges over all the attributes of the employee: employee number, employee first name, employee middle initial, salary, joining date, all those attributes. Then employee X. So it will give all the details of employee, and I have written the condition and. You can use this operator also. You can use this operator and like this also. Okay. X dot salary greater than 10,000. So in this way you can write. Let's see another question. Select first name, last name of employees having salary greater than 6,000. So here you have to select two attributes. So what you will write? First of all you will take a tuple variable. I have taken the tuple variable x, which will ranges over all the attributes. So I am writing x dot first name, x dot last name. These two attributes I have to select. We will apply on employee relation and passing the attribute x, tuple variable x, and x dot salary is greater than 6,000. Now let's see another example. Write a query in tuple relational calculus to select birth date and address of employee. The name of the employee is RP Bhardwaj. Here R is the first name, P is the middle initial, and last name is Bhardwaj. So how to write? Select birth date and address of employee. So first of all, we will take a tuple variable. I have taken the tuple variable X. This may be T, this may be W, any variable. So X dot birth date, comma, X dot address on employee with the tuple variable X, and X dot first name is R, and X dot middle initial is P, and X dot last name is equal to Bhardwaj. So in this way you can write your queries in tuple relational calculus. Another category is domain relational calculus. In domain relational calculus, first of all, understand with the example. Here we will take a variable that will be not the tuple variable, that will be domain variable, which will be ranges over only a single attribute. So here retrieve the name, joining date, employee whose salary is 15,000. So what are the variables here? For example, if employee relation is there, different attributes, employee number, that will be P, employee first name, that will be Q, employee middle initial, that will be R. So whatever the attributes are there, corresponding to each attribute, we will take the domain variables, right? And we will write the query, answer retrieve the name, joining date. It means that Q in the corresponding, if Q variable, domain variable belongs to name and S belongs to joining date in the employee table, so Q S. These are the bind variables. Bind variables are existential P, Q, R, S. Employee, we will pass the variables, domain variables, and R. Salary salary will correspond to R is equal to 15,000. So and where sigma, there exists is a existential quantifier, and I told you in the previous class that this is a bind variable. So this was all about the relational algebra and relational calculus. Now what are the questions which may be asked in the examination? So first of all, in the examination they may ask either queries, to write the queries of 10 marks or 8 marks in relational algebra or in calculus. Second thing, okay, what is the relational algebra? What are the various operators? What is the complete set of operators? And what is the derivable operators? Right? What do you mean by outer join? Why outer join is used? And what are the different types of outer join operators? Explain each with the examples. After that, then what do you mean by safe? What is the safe expression? What is the unsafe expression? Then what is the relationally complete language? What do you mean by the relationally complete language? Then write the queries in relational tuple relational calculus and domain relational calculus. So these are the various questions. What is the difference between the Cartesian product and join, right? And there may be questions on the various operators in the examination. So all the best. Thank you very much.